Corporate finance practice problem using Excel. Standard deviation, variance, and coefficient of variation. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We're going to apply some standard statistical type of analysis that will typically be applied to a data set. We're going to be using these tools in future presentations in more of a corporate finance type of situation, oftentimes using it to make projections about things into the future and measuring things such as risk and so on. So note this is a standard statistical type of thought process here. You can find a lot of information about this out on the internet and whatnot on YouTube and other places as well, just in terms of math theory. And you can look up things like the standard deviation, the variance, and the coefficient of variation. Then we're going to take those tools and we'll apply them in more of a corporate finance type of setting in future problems. So a quick recap on some of these statistical kind of numbers. We have the population mean, which is the average of the population data points. The variance, which is the disbursement of a set of data points around the mean. So these are common types of things we want to do with a data set, meaning first we calculate oftentimes the mean or the average to find kind of that middle point. Remember, the mean is basically the average. Something like the median would be the middle point in the data range of the data set. But we're usually thinking first about the average, and average being kind of around the middle. Typically, we're taking the average, and then we want to think about basically the disbursement or variance of the data around that average point. How widely dispersed are the data points around basically the mean? So if we were to take a simple data set, just like 1 through 5, if we just count up 1, 2, 5, typical things we might do to this data set in order to get a better understanding of it would be maybe 1, sum it up, get the total of it. That's going to be 15 in this case. Then we might compare that then to the number of components in the population size. This one obviously has 5 components, 1, 2, 3, 4, 5. So we can then say a count. I'm going to count those up using a count formula. So this is the fancy way to count them. Equals count in Excel. So we'll count these up and it'll just take the units or the cells with units in them. We have the 5 there. Now, if we divide that out, the total divided by the population size, 15 over 5, we then get the mean or the average, which in this case would be 3. That's one of the first things that would basically be done here. Now, note the mean is kind of the same as the median in this case. Remember, the median is when you take basically the middle number. You pick up the middle one, which sometimes can give you a different data set depending on the type of data that you have. But normally, we're going to start off with that mean here, right? And the calculation, you might see it written like this. It's going to be the calculation of the sum of the data points divided by the number of points, which is going to be the population size. Now then, the next thing we might want to get is the variance. So now that we have the mean, we want to think about how widely dispersed the data points are around that center. Because that, if we're trying to make projections into the future, trying to see what the actual population is, then we're going to want to basically, or get a characteristic of what that population is. We want to think about how spread out it is from that, what we kind of think about as the center point. So we could do a formula like this to start off, the population variance, which would be the sum of each data point minus the mean or average that we just calculated in this data set, to the power of 2 squared, in other words, divided by the population size, or n. So if we were to run that out for our 1 through 5 data set, it would simply look like 1 minus 3 squared plus 2 minus 3 squared plus 3 minus 3 squared plus 4 minus 3 squared plus 5 minus 3 squared. So notice what's happening here when we take this number minus the mean, each number in our data set minus the mean. The closer it is to the mean, the smaller the number that we're going to have as a result. So the closer it is to the mean, the average, the smaller the number that we're going to have as a result of these items. Also note that here, the 1 minus 3, you would then result in a negative number, whereas if you had the 4 minus 3, you'd have the positive number. By us squaring each of them, that's going to result, 1, in them all becoming positive. So now we're having positive numbers because we're dealing with distance here. So that's one thing that we kind of want, and it'll amplify the result due to it being squared here. So we can do this with a mathematical kind of calculation here. In Excel, it would typically be mapped out something like this. So let's do it in Excel. Same data set, which is going to be 1 through 5. We're just going to say equals that 1 through the 5. So we'll bring that on down to 5. And then we'll compare that to the mean or the average. Let's calculate it again. This time, let's use a formula to do it. This is going to be equal to the average, and double click on this of this data set of numbers, 1 through 5. That's going to give us 3, which we see here as well. Now, every other cell, I'm going to say equals that 3 to bring it on down instead of doing the average 5 times. And then I can drag that down. So every cell equals the one above it. That sometimes is an easy way to populate your data set in Excel. And then the difference here, we'll take the difference here. And now we're basically doing the 1 minus 3. We're taking the difference of each one now in a vertical fashion. So 1 minus 3 would obviously be negative 2. 2 minus 3 is going to be negative 1. 3 minus 3 will, of course, be 0. 4 minus 3 is going to be 1. And 5 minus 3 is going to be 2. Now, if I add up this data set, of course, because we have the negative and positives around the mean, and we're going to get 0 in this case. So what we want to do then, these negative numbers, when we square it, will basically go away because we're talking about distance from the average, right? We're talking about different distance from the middle here. So we want these to basically be positive differences, and when we square it, it'll kind of amplify the differences as well. So let's do that. That's of course bringing it to the power up top for each of these. So now we would get kind of the result of all these, and then we'll sum them up, which would be adding them up in our formula. So this will be the 2, I'm going to say shift 6 for the caret, and then 2, right? So then I'm going to say this is going to be the negative 1 cell, shift 6, and then I'm going to say 2. And so now we've got obviously a positive number, and it's 4 now, and then this is going to be positive 1. This will be this one, shift 6 and 2, which is 0. This is going to be 1, shift 6 and 2. We have the 1, and this is going to be 2, shift 6 caret and 2, and so there we have the 4. So now we have a positive set of numbers. If I sum these up, then I'm going to sum these up, and there we have it. And this is going to be our total. We'll call this the total. All right, and then we're going to take the population size here. So taking the population size, which once again we can count them by saying equals count. So I'm just counting the number of items in the population now, which are 5, right? It would be sum of these or the count of those, which would be the 5 items. And if I underline that, now we divided by the 5 here, that's going to give us our population variance. So the population variance then is the 10 divided by 5. So that could be a useful number, but note that we had to square it. So oftentimes then the next step is to go to the standard deviation, which is kind of removing the squared portion, right? The squared helped us to basically amplify the number and get to basically positive numbers up top. So then at the standard deviation is simply going to take that population variance and take the square root of it, kind of removing the square component, right? So now we're going to say this, and we could do this with a formula. This would be the square root, square root, which would be SQRT in Excel, of this 2, and then enter. I'm going to basically add some decimals there, and there we have that. So we just took the square root of the population variance. That gives us then our standard deviation. Now if we compare that to the mean, so the mean or the average, we can say mean or the average, then we're going to say this is going to be the mean or the average, which we had was the 3 before that we've calculated a couple different ways, and that will then get us to the coefficient of variation. Coefficient of variation being equal to the 1.41421 divided by the 3, by the mean, giving us, and then I'm going to add some decimals. Sometimes this will be represented in a decimal format or sometimes in a percent format. Now note that this standard deviation is going to be basically in the units of the items that we're measuring in. So if it was dollars, we're talking basically in dollars. But if we have the coefficient of variation, that's going to be comparing, and if we have 2 different data sets, it actually compares the variation a little bit more easily. So we can have different data sets that have a similar dispersion, but they have different dollar amounts, and this coefficient of variance will make it easier to see what that what that dispersion will be as we compare the two different data sets. That will become more apparent as we go through practice problems in the future and do the comparisons on the side-by-side comparison. Now let's do some of these with the formulas on the left-hand side. So if I was just to do this quick hand on the formulas, we can say, okay, the average or the mean, we can do this equals the average in Excel. We call it the average in Excel. And we would then just take this sum of data as we did before, or the average of them, that data range, and that would give us then the 3. The standard deviation, we can take the standard deviation, this equals the standard ST, and then we have the STDEV for the population or the sample. Notice it could be a slightly difference for the population or the sample. We're going to be using population here. Sample meaning you don't have all the data, it's a sample of the data. And the population meaning we have a full data set that we're taking a look at. So we're going to take the standard deviation of P. We could sum up this data set again, and then we get to 1. We can then add some decimals, adding some decimals, then we get to that 1.41 and so on that we have over here. And then we have the variance, which we can get to by saying this equals the variance, and we're going to say of the population again. Variance of the population, picking up then 1 through 5 and enter. And so there we have our 2. So that's going to be our population variance. And then the coefficient of variation, once we have these two numbers, we can then take the 1.414 and so on standard deviation divided by the mean or average, which would be 3. And then we can add some decimals to that. And then we get back to this 0.47. So let's think about it again. Now let's take a look at this again with two data sets side by side. They're going to be similar in nature, but they're going to have different dollar amounts, or different amounts that will be included. You can consider them as dollar amounts. So we have first data set 1, 2, 3, 3, 5, 6, 7, 8, 9, and 11. And the second data set being 20, 40, 60, 60, 100, 120, 140, 160, 180, and 220. Now you can see the second data set is derived by simply taking the first data set times 20. So you'll have a similar kind of characteristic in terms of we're just amplifying it by $20. So when we think about the comparison of these data sets, you would think they would have things in common, even though we have different total amounts involved. So if you're thinking about dollar amounts, for example, and you were trying to compare two different data sets, you might want to know about the outline of the data set and the variance of the data set, even though you're talking about two data sets with two different dollar amounts. The similarities could basically tell you something about possibly those data sets. So let's go ahead and do these calculations again. So we'll do a similar type of process. Let's put our data set 1 into this first table. I'm just going to say 1, and then I'll copy this on down until we get to the end of the data set, which was 11. And so there we have that. Let's calculate then the mean or the average. I'm going to say this is the average. Double click on that, summing up the data set, and then enter. And so we have the average. Let's add some decimals, numbers, couple decimals. Then I'm going to go underneath it and just say equals the cell above it, and I'll copy that on down. So that'll be it, and then I'll copy that down so all cells will equal the one above it, which will make it a little bit easy to calculate. Oftentimes, useful tool. Number group. Let's add a couple decimals there. So there we have that. And then we can take a look at the difference. So first we had the 1 minus the 1.5. Let's go ahead and add decimals here to all these first. Number group, add a couple decimals. So negative 4.5. And then if we had the second piece of data minus the 5.5, negative 3.5. 3 minus 5.5, negative 2.5, 3 minus 5.5, negative 2.5, 5 minus 5.5, negative 0.5, 6 minus 5.5, 0.5, we got 7 minus 5.5, 1.5, 8 minus 5.5, 2.5, 9 minus 5.5, 3.5, and 11 minus 5.5, giving us the 5.5. So now we're going to square all these. We'll take each data set and square it. So this equals the data set caret 2, squaring it. I'm going to copy this one down. Let's go ahead and put our cursor on it and autofill that on down. And then we'll add a couple decimals, number group, add a couple decimals there. So the difference column, because we have the positive and negative numbers, is not going to give us, the distance that we would basically like as much because it has those negative numbers. So when we squared it, you could see we have all positive numbers here. If I was to sum that up, equals the sum of these items, That's going to give us the 97. Let's add some decimals to this whole thing here instead of one at a time. Let's do it the whole thing together, and then we'll take a look at the population size. So let's put some underlines under these two, font group and underline. Population size, we just count the items in the population. So I'm going to use the trusty count function this time, count. I want to count these items from here to here, and then enter, and that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all it did. And there's the 10. We're going to say, let's underline that. Put an underline there. Population variance then. The population variance is going to be equal to the 96.5 divided by the 10. So there we have the 9.65. Let's calculate then the standard deviation on it, which would simply be the square root of that. So this is like the squared value, so we want to bring it back. So, and if this was dollars, this would be like in square dollars, right? We want to bring it back to the unit. So I'm going to say this is going to be equal squared, the square root of, not squared, the square root of the 9.65. That's going to give us the 3.11 standard deviation. If we compare that to the mean or the average, which we calculated to be, you'll recall, the 5.5, underlining that by going to the font group and underline, that'll give us the coefficient of variation for the population, which is going to be equal to the standard deviation divided by the mean, and that's going to give us that 0.56. Now let's see if we compare this. Let's put a total here, total. Let's compare this to data set 2. So let's do a similar kind of thing with data set 2, picking up the data and copy that on down. I'm going to select the whole thing this time and add some decimals before we even start this time. Number group, add a couple decimals. Then we'll autofill that down to the 10 components for all of our data. Let's calculate the mean, which is going to be the average equals the average of this data set. And enter. I'm going to say this equals the one above it, and then copy that down. We'll put our cursor on that fill handle and copy it down. So there's the 110 all the way down. Then we'll do the subtraction, subtracting it out. So the 20 minus the 110, negative 90. 40 minus the 110, negative 70. 60 minus the 110, negative 50. 60 minus the 110, negative 50. You see a similar trend that we have here with regards to the distance from the mean, meaning the spread of the data from kind of like the center point or mean that we would calculate. So we'd have the 100 minus the 110. We've got the 120 minus the 110. We've got the 140 minus the 110. We've got the 160 minus the 110, the 180 minus the 110, and finally the 220 minus the 110. So again, you can see some similarities here with this disbursement of differences to this disbursement of differences, even though we have, of course, different dollar amounts that are involved. Now I'm gonna remove the negative numbers by squaring it, and this will amplify the difference as well. So we're gonna say this is gonna be equal to this number. I'm gonna say shift 6 to the power of 2. Squaring it, let's copy that all the way down. So if we copy that all the way down, there we have it. Making this cell a little bit larger because that last one is a big number. Give it some room. It's a big guy. Font group and underline. And then we got the population size. So this is going to be the total. We'll just pull the same over here. Population size. The size of the population then is going to be, let's do the total first. Total is going to be the sum of these. So there we got the 38,600 population size. Let's do the count equals the count. So we'll take the count of, and we're going to pick up these numbers. It's just going to count them out. There'll be 10 of them again. Underline, font group, and underline. And that'll give us the population variation. Population variation, which is going to be equal to the 38,600 divided by the 10. That's going to be the 3,860. So that's the population variation, and then we're going to take a look at the standard deviation. Standard deviation. So notice again, these population variations, because they're amplified now because we squared them, aren't as comparable, right? When they're not in like squared units. If they were dollars, they'd be in like squared dollars. So now we're going to basically take the standard deviation, the square root, in other words, of the population variance, which will be equal to the square root square root of this cell, so we're just square rooting it, and that'll give us the 6213 on the standard deviation. Now, these two numbers are now in dollars, but they're still not very comparable, right? I would like to be able to see something that shows that the variation is the same basically between the two, and we can't really see that in the standard deviation here. So let's take a look at the coefficient of variation by then picking up the mean which we calculated to be equal to the 110, underline that, font group and underline, and that'll give us then the coefficient of variation being the 6213 divided by the 110. And so there's the 0.56. So notice that these two gives us a better kind of idea if we're comparing two different data sets about the disbursement of the data around that kind of center point or the average point. And don't get the center point of the mean mixed up with the median, but the mean, the average point that we're talking about, which usually people kind of express as the center point or the average of the data, and then the disbursement of the data around basically that average can be nicely seen here with the 0.56, even though, again, we're talking about different amounts. And if you're thinking about financial type of matters, we might be talking about different data sets that have different dollar amounts that are involved, but have a similar disbursement, once again, around the mean. Now, you could do that again with the calculations down below. Let's try to use Excel and do this without a full table. Now, it's really useful to do the full tables, by the way, because that gives you a better understanding about what's happening and just looking at the data. Because remember, when you're looking at these data sets, you're trying to get a different perspective about the data sets that tells you something about them that might be useful to whatever you're trying to do. So actually mapping out the data sets in this format can give you a visual look at what these data sets are doing. I mean, just by looking at these two data sets, we could start to see, there's something similar about these two, right? We could start to pick things up just by doing the calculation. So it's worthwhile to do that. Remember, that's what statistics is basically doing. No one stat, oftentimes when you're looking at a data set, can tell you everything you need to know. The average doesn't tell you everything you need to know. That's why people can lie about numbers, right? Because they use one data set and they build a whole story around one small piece of truth. And one small piece of truth isn't the whole story. You got one small piece of truth and a bunch of lies, right? So what you want to do is look at it from many angles so that you can try to peer in as many angles of truth that you can find and put together a story that actually is as close to the truth as you can get, right? So if we have over here, we could do this with the calculations with Excel, though. So the average would be the average, and this would be like the mean or the average. So the calculation in Excel is the average. So we'll take the average of these, 5.5, data set 2, if we took the average. So equals average, double clicking on that and just select the data like you would with the sum function. There we have it. If we take the standard deviation, that's going to be this ST. I would type in ST, and then you got the standard dev of the P or S. Now, these could come up to slightly different results. If you want to get more research on those different results, then you can look this stuff up. There's a lot of great math, just straight math kind of calculations. These things are often used, of course, when you're taking a look at sample sizes and things like that. But we're going to use the population here as if we have the whole population. And we're going to be summing up then, or not summing up, but taking the data kind of similar to what you would do in a sum formula of this range of cells. There we have it. Let's do it again. This is going to be equal to the ST standard deviation of these items, picking up these numbers. All right, and then we have the variance. The variance is going to be equal to the VAR. So variance, once again, we have the population versus the sample. I'm going to take the population, being consistent here, picking up the numbers on this one for data set 1. Similar kind of format. And then the variance, P, picking up the numbers for this data set. And so there we have it. We could see these numbers lining up. We got the 5.5, the 3.11, the 3.11, the 9.65, the 9.65, and then the coefficient of variation being equal to then the mean divided by the standard. I'm sorry, hold on a second. It equals the standard deviation divided by the mean. So there we got the 0.56. Doing it over here, the standard deviation divided by the mean. So we got once more standard deviation divided by the mean. So there we got 0.56. Okay, so there's the 0.56 here, and then the 110, of course, matching the 110 in the second data set, the 6213 standard deviation matching out the 3860 variance matching out here, and then the 0.56, of course, bottom line number for the coefficient of variation. So get an idea of these kind of things. These are really, really useful tools to analyze data sets. They're used all the time in different kind of settings, and they become useful, and we'll take some of these tools and apply them out to situations, possibly forecasting, prediction type of situations in future presentations.